All right, we're going to try the next section. This is 16.2, compound events. Oops. All right. Now in compound events, remember we did compound inequalities, and or are the two types of compounding. Well, the probability of A and B happening these are independent events. And what independent means is one does not affect the other. So if you're flipping a coin and rolling a six-sided die, those would be independent events. So what's the probability that the coin is tails and that the die comes out 3? No, how about a 2? The die comes out a 2. Now the probability of A and B happening is probability of A times the probability of B. Now in this case, the probability that you get a tail when you flip a coin is 1 out of 2, right? Heads or tails. Times probability of getting a 2 on a six-sided die is 1, 2 out of all 6 possible numbers. So it's 1 out of 1 times 1 is 1, 2 times 6 is 12. That's how easy it really can be. Let's see. How about we use this set of table to help us with the next one? What's the probability of the red being even and the blue, I should have used some other color here. So red even and the blue one is a 3. So what's the chances that that's going to happen? Well, the red being even, there are 36 possible things here. Or we can just say, we don't even have to use that. Let's just think of a six-sided die being even. There's 1, 2, 3 of them. So 3 out of 6. What's the chance that a blue die is a 3? 1, 3 out of 6. So ignore that. 3 times. Now you can reduce first or after. 3 times 1 is 3. 6 times 6 is 36. And we know 3 goes into 36 12 times and into itself once. So 1/12. All right. So that's and. What about or? Now these are dependent on, somewhat dependent, like they can overlap. So probability of A or B equals, now this is going to be dependent on something else, but let me show you what the formula is. probability of A plus probability of B minus the probability of A and B happening. So I'll show you an example of that first. So the probability of, sorry about that, hope I didn't move the camera much. Can't tell. Guess not. All right. Probability of, let's see, how about the red being a 2 or the blue being a 4? So this is a little different now. We've got, if you roll 2 dice and you roll a red die and a blue die, these are all the possible outcomes you could have. Now, if you roll 2 of the same color die, that's not what we're talking about here. We're talking about one distinct die and a different distinct die so we can tell them apart. Now, if you roll a 2 on the red, there's 1, 2, 3, 4, 5, 6 ways that can happen when you're rolling 2 dice. If you roll a 4, so there's 6 out of, this total is 36. 6 by 6. 6 times 6 is 36. The number of ways you can roll a blue 4 is 1, 2, 3, 4, 5, 6. Now, how many ways can you both roll a red 2 and a blue 4 at the same time? Red 2, blue 4, just one. So there's 1 out of 36 that we have to take away, because if we count these up and we count these up, we're counting the same one twice. We only want to count it once. So this comes out, when you add 6 and 6 is 12, minus 1 is 11 out of 36. Let's do another example with these before we move on to the marbles. All right, let's erase this for a minute. Just so we have a little bit more room. Hopefully you wrote all that down. If not, you can write it down later. All right, probability of red less than or equal to 4. Or, I might have to add room here. Yeah, I definitely will. The blue being greater than or equal to 5. Now in the book, they use small and big, S and B, and they just use S less than or equal to 4 or B greater than or equal to 5, that type of thing. But we can follow it here. The chances that red is less than or equal to 4, well, there's 1, 2, 3, 4 different rows where red is that, and there's 6 in a row, so 6, 6, 6, 6, 4 sixes is 24 out of 36 are going to be that. Blue greater or equal to 5, blues that are greater or equal to 5, 2 rows, so that's 12 out of 36, minus, now, where do those 2 overlap? Less than 4, greater than 5. That's these 8 right here. So 8 out of 36. Well, 24 plus 12 is 36. Minus 8 would be 28 out of 36. And 28 and 36 can reduce by 4 to 7 over 9. Okay. So that's how you would work with or in this situation. Now let me show you a different situation These are called mutually exclusive. And what mutually exclusive means is the result of one does not affect the result of another. So let's say we have a bag, and in that bag there are 4 red marbles, there are 5 blue marbles, and there are 2 purple marbles. That's in my bag. What is the probability that I get I'm just going to pull 1 marble out, and that's all I'm going to do. What's the chance that I get a red or a blue? Now we know the chance of getting a red, that's 4 out of, let's see, that's 4, 9, 10, 11. 4 out of 11. So the probability of getting a red is 4 out of 11. The probability of getting a blue is 5 out of 11. Is there any way I can draw both a red and a blue by just drawing 1 marble? And the answer is no. So there's no overlap. That minus part's not going to happen. That's what happens when you have mutually exclusive situations. When they're mutually exclusive, then the probability of A or B is probability of A plus probability of B without the minus A and B. But they have to be completely separate problems. So this comes out to 9 out of 11. The last little bit is what happens, or what's the probability of purple or red. The probability of getting a purple is 2 out of 11. The probability of getting a red, again, is 4 out of 11. And so the probability of purple or red is 6 out of 11. And that is all I have for you today. Thank you very much.